Continue from where you got.
Okay.
Yeah.
Okay, so let's begin with the implicit differentiation. So today you said you want us to learn implicit. What else do you want us to? So list them down.
Rate of change.
Implicit differentiation. Okay. So
Rate
that
of
is one of it. Then you want us
integration.
to also learn rate of change.
Yeah.
Okay. What again?
Integration.
Integration.
Yeah.
Okay. That's all.
So that's the main things. After that, then there is time.
Okay. So let's begin with the implicit differentiation.
Okay.
When we say implicit differentiation, we are having to a function. Let's say if we are having a function. So let me tell you to implicit. If we are having a function, say y is equal to, let's say 2x plus 3, this type of function, we call it an explicit function. The reason why it is an explicit function is because of the dependent variable, you see that y depends on x. In order for us to know the answer for y, we have to first of all get the answer for x. So we say that y depends on x, right? So when the dependent variable is made the subject, then we do say that that kind of function is an explicit function, right? We've been able to separate the dependent variable, then that is an explicit function. So with this, when you are finding change in y over change in x, dy dx, it is easy. You just have to just differentiate it and you're going to get what? 2. But when we see an implicit differentiation or an implicit function, it is a type of function in which the dependent variable has not been separated fully from the function. So if, for instance, if I give you x squared plus y squared is equal to 1, this is an implicit. Implicit means that this guy, normally y is the dependent variable. So this guy being the dependent variable is not made the subject yet. So this type of function, we term them as what? Implicit function. And whenever we are finding change in y over change in x, we say we are doing implicit differentiation. So that is where the concept is coming from. So something being implicit or explicit just depends on whether the dependent variable is made the subject or not, right? Now let's get right into how do we find the differentiation? How do we differentiate an implicit function? So one of the key things that you should know is that for implicit function, so key things to note. So key things, and let me call it keys. Some of the keys to know is that, for instance, whenever I'm doing, let's say I'm having y squared, but I want to do d dx, right? I want to do d dx. D dx means that I'm differentiating y with respect to x, right? You see that the variables aren't the same. We are differentiating with respect to x, but the variable that we are doing it is y. What happens? This is what is going to happen. We are going to differentiate it alright, as in the concept of differentiation. So we're going to get 2y, but because the variables aren't alike, we're going to do v of the variable that you differentiated. We differentiated the y divided by the x. So this concept should be clear. So that is to say that if we differentiate y squared with respect to x, we're going to get to 2y dy dx. Likewise, if that concept is also borrowed here, if we are doing d du with respect to y squared, then what is the answer going to be? We differentiate y squared using the concept of differentiation we are having, right? And that is going to give us what? I'm waiting on you. What is that going to give us?
2y.
2y. Then d of what? You said?
2y divided.
dy d what? That is u, so du, right?
That is u.
Yeah, not v.
Okay.
So Good. So that is the whole concept. If this concept is clear, then meaning you are a step forward in understanding it. And the other concept you should also take note of: when you differentiate a constant, you get a 0. So that should also be in your mind. So that being said, we proceed in solving an actual question. So questions. For instance, if they give us this question, say x squared plus y squared is equal to 1. Find dy dx. How are we going to solve this? So we are going to differentiate everything with respect to x. So that is to say that we are going to find d dx of x squared plus d dx of y squared is equal to d dx of 1, right? Doing this, we know that when we differentiate x squared with respect to x, we're going to get our 2x. When we do this here, we are going to get what? 2y, but we're supposed to get the y, the x to what? Based on the concept I explained earlier. And whenever we differentiate a constant, what are we going to get? 0, right? From here, what we'll do is we make the y, the x, the subject.
Okay.
So making that the subject, then you're going to see that we are going to have 2x plus 2y dy dx is equal to 0. So we have 2y dy dx will be equal to negative 2x. From here, we can divide both sides by 2y. We divide this side too by 2y. Then we're going to have that dy dx will be equal to negative of x divided by y. The reason being that the negative 2 will cancel, sorry, the 2 here will cancel the 2 here. I hope that concept is clear. Okay, good. So this is just an introduction on the implicit differentiation. So I'm going to write some more questions with you. So I'm coming, let me look for questions, then we'll proceed. So questions. So we have question 1. We are finding the derivative of the following: minus 3y is equal to x cubed minus y. Then question number 2, we have y squared minus x squared is equal to 1. Question number 3, we have x minus y squared is equal to x minus 8. Question number 4, we have cos of x y squared is equal to y squared plus x. Then question number 5 here, we have x squared plus 2x squared y plus 3xy is equal to 0. So these are the questions that we are having. Now, continuing, then we're going to solve the questions step by step. All of them. If you're able to solve all these questions, then I'll give you a similar one to also try your hands on, and we'll move forward. So let's say that you've met these questions in exams. The first one, let me copy and paste the first one. You've met this first question in exam. You've met this first question in exam. We have seen that find dy dx. So we are going to differentiate this question. Solving this, you can see that x squared and y, this is product rule. Product rule. And what does the product rule say? The product rule says that if you are having two functions combined, differentiate the first one, multiply by the second one, plus do the opposite of what you did. So now you multiply by the normal one, the other one that you differentiated, then you differentiate the one that you didn't differentiate. So this is the product rule. So we are going to apply the same concept. If x squared is a function and y is a function, then what is going to happen? You get it? But here we are having 4x squared, so we are going to include it. Then we consider 4x squared as a function on its own and y as also a function on its own. So if we differentiate 4x squared, what are we going to get? We're going to get 8x, right? Then we multiply by the y. Then plus, now we are going to do the opposite. We are now going to do y being differentiated. When you differentiate y with respect to x, what are you going to get? What are you going to get?
When you differentiate y.
Is that yes with respect to x?
Yeah. dy dx.
You get dy dx. Get close to the mic so that I can hear you. Dy dx. Good. So when that is done, you now multiply by 4x squared. You get it? Good. So that is exactly what we are going to do. So coming here, we are going to differentiate this. We get 8x. We multiply by this y. Plus we differentiate y. We are going to get the y dx. Then when we multiply by the 4x there, we are going to get the 4x squared. Now we're coming to differentiate negative 3y. When we differentiate negative 3y, we're going to get negative 3 dy dx is equal to, now we are coming to differentiate x cubed. We differentiate x cubed with respect to x, we get 3x squared. And when we differentiate a constant negative 1, we get a 0. So now what do? We group like terms. We group like terms and like terms with respect to dy dx. So then we have an 4x squared dy dx minus 3 dy dx. Then the remaining is sent across the equal to. So we're going to have 3x squared. When this moves over the equal to sign, it is going to become a negative. So we're going to have negative 8xy. From here, what do? We are going to factorize dy dx. So on factorizing dy dx out, we're going to have 4x squared minus 3, right, is equal to 3x squared minus 8xy. That being said, we want to make dy dx the subject. So we're going to divide this side by 4x squared minus 3. Whatever you do to the left hand side, do same to the right hand side. So we divide here 2 by 4x squared minus 3. Looking, this is going to cancel that or divide it, right? So we're going to have that dy dx will be equal to 3x squared minus 8xy divided by 4x squared minus 3. Do you see that?
Yes.
Yeah, so then we are done. Any questions so far? Do you have any question?
No.
Okay. So then, I want you to try your hands on the second one and give me the answer before I come in.
Okay.
So you're having 2 minutes to try your hands on it.
Equals x on y.
So you said dy dx is equal to what?
X on y.
X out of y.
Yeah.
Okay, so let's do that and see. This is going to give us 2y dy dx. This is going to give us negative 2x is equal to 0. Then we make dy dx the subject. We're going to have dy dx, 2y dy dx is equal to 2x. Since we want dy dx, we're going to divide this side by 2y. We do the same to this side, 2y. This now is going to give us dy dx will be equal to 2x divided by 2y, which equals x divided by y. Okay, so then your answer is correct. So good job done. Now let's move on to the other question. That is the third question. So by now, this should also be easy. So try your hands on this one.
Okay.
This one too as well. Okay, so I've received a prompt that the meeting is going to end in 10 minutes time. So when it ends, right, I'll send you a link.
Okay.
But first of all, we will join the same link again. If it happens to be that we can't join, then I'll send you another link.
Okay.
Your 2 minutes is up. Are you done?
No.
And this one you're taking time.
Okay,
So what did you get?
I was stuck. I'm clear.
So where are you stuck? You take me through the process. What did you do first?
I differentiated your
What did you get?
dx dy.
So you had dx dy first.
Yes.
Dx dy.
Yes. Multiplying y squared.
Multiplying dy dx or dx dy?
X dy.
Why dx dy?
I'm differentiating x.
It says dx dy multiplied by y.
Y squared.
Oh no. So we differentiate all of them with respect to x. So we are doing dx of xy squared is equal to dx of x minus dx of 8, right?
Okay.
But if we are doing the ddx of xy squared, we use the product rule. So first, we're going to differentiate x. What are we going to get? 1, right? So our first input is we differentiate the x, we get 1. We multiply by y squared, so we get y squared, we've written. Plus, now we are going to differentiate y squared alone. What are we going to get? We are going to get 2y. But because we are doing it with respect to x, it will become dy dx. You understand? So if you differentiate y squared alone, you're going to get 2y dy dx. But are you done? No. You have to multiply by this guy again, x. That is the product rule. So what did we do just now? First of all, we differentiated x. We had 1, but we don't bring it, right? Yeah. And we multiply by the y squared because that is the policy. We are done. Plus, now we are going to do the opposite. When we differentiate y squared, we're going to get 2y, but because it is with respect to x, we say dy dx. Then now we multiply by the x again to it. So that is the chain rule being applied over there. Now, when that is done, we say it is equal to, when we differentiate with respect to x, we get 1. When we differentiate a constant, we get a 0. So then we proceed in making dy dx the subject. So y squared plus, when we multiply this, we're going to get 2xy dy dx is equal to 1. Now, making dy dx the subject, we are going to have 2xy dy dx is equal to 1 minus y squared. Now from here, we make dy dx the subject by dividing this side by 2xy. We divide this side by 2xy. Now dy dx will be equal to 1 minus y squared, all divided by 2x and y. Is it clear?
Yeah.
Okay. So now we move on to the next question. So where did you get stuck?
I was doing the x dy.
Don't do that, right? I'm even wondering why you started doing dx dy. It's always dy dx. So the concept I was explaining, if we are having y cubed, then we are doing d dx. Again, we do our normal differentiation that we know. So this gives us 3y squared. But because this is y and this is x, so you just do d of what? With d of the y, the variables aren't the same, divided by dx, you add this to it. Meaning when we differentiate y cubed, we're going to get 3y squared dy dx. Is it clear? Okay. So that being said, we pick the next question. The next question is question number 4. I hope we are able to solve it before the video hangs up. So this is question number 4. So we paste it here. So for question number 4, so this is your try 3, but I'm going to work it out together with you. So you see that this is also chain rule. Chain rule because cos is a function on its own, then the x and y are also functions within. So if we are applying the chain rule, what does the chain rule say? The chain rule says that if we are having a function and within the function we are having another function, say g of x, what we are going to do is that first, if we are to differentiate this, let me do d dx. If we are to differentiate this with respect to x, first we will differentiate the outer function, right? And we won't do anything to the inner function. Later when we are done, then we multiply by the derivative of the inner function. That is what the chain rule is about. So that being said, if we are to solve this question, then what we are going to do is that we are going to ask ourselves that what is the derivative of cos of x? When you differentiate the cos, what are you going to get?